Hello, we are presenting text-based motion synthesis with a hierarchical two-stream recurrent neural network. Our goal is to generate 3D human motions from complex natural language sentences describing single or simultaneous actions. To summarize our main contributions, we design a hierarchical joint embedding space to learn embeddings for pose and language simultaneously. We train a sequential two-stream network to separately learn upper and lower body poses. We use contextualized BERT embeddings and additional loss terms with a pose discriminator to condition our training process. We train our network using poses and sentences simultaneously. Our hierarchical pose encoder and sentence encoder map the input poses and corresponding sentences into a joint embedding of language and poses for the upper and the lower bodies. Our hierarchical pose decoder then decodes these embeddings to a sequence of poses to generate the output motion. We compare our method with two state-of-the-art methods of joint language to pose and Lean et al. We show results for locomotion, arm movements, and complex activities. We first observe the output motions for a sentence describing a direction. We see that our method generates a motion which walks correctly in a counterclockwise circle. We then observe a sentence describing multiple action sequence with a direction, given number of steps, and handedness. Unlike JL2P and Lean et al., we see that our method follows the correct action sequence of walking forward and turning 180 degrees on the left foot. It further generates the correct step count. Here we see an example where our method generates motion with different speed. We see a sprinting motion as well as a fast walking motion with correct direction and step count. Now we move to various arm movements where the sentence depicts which arm is used for the action. As we see, our method can replicate arm movements for playing guitar using both right and left hand as mentioned in the sentence. We also see a wiping motion in a clockwise direction with the left hand. The state-of-the-art methods fail to generate these arm movements. Next, we show a complex activity of dancing, which involves simultaneous arm and feet movement. Our method is able to correctly generate these dance movements. We show an activity involving a low side kick using the left foot. This is also replicated correctly by our method. We also show activity requiring both arms and right foot movement. Although our method does not generate proper arm movement here, it can produce kicking action with the right foot. We also show a motion involving multiple actions like walking, being pushed back, and walking forward again. However, our method falls short for sentences which are rare in the training dataset. For example, a person performs a cartwheel, a person doing a handstand, as well as rare activities involving the upper body. Thank you.